All right, we're going to talk about heat transfer again today. Make sure you have your doodle notes out and you're ready to go. Let's begin by what heat transfer is. It is thermal energy transfer. Think about thermometer, thermos. Okay, thermo means heat. Okay, it is the flow of heat due to a temperature difference, being hot or cold. That's going to make the heat transfer. It's transferred through conduction, convection, and radiation from hotter to cooler. Specifically, conduction. Remember, conduction is like the conductor holding his baton and waving it. He has to hold it for it to be conduction. So the heat energy moves in a solid by conduction. When it says a solid, that means a solid object, a table, a pole, a cup. The motion of the particles in the hotter part transfer their energy through vibrations to nearby ones. So what that means is the molecules are moving around within the solid. Okay, and as they start moving around and vibrating, they're moving out and they're transferring into something that's nearby. So conduction, when we touch a hot stove, if we iron a shirt, ice if it melts in your hand, or walking without shoes on a hot day. That heat's going to transfer right to your bottom of your foot and you're going to say, ow. You had finished all your conduction notes. You are ready to move on to convection. Remember, convection is a little bit different. It's like those convection currents in the mantle. The heat energy in liquids or gases is transferred by convection, not in a solid. The hot fluids rise up while the cooler or cold fluids sink. This rising and falling or rising and sinking is called a convection current. It's that constant movement of heat going up, cooling off, and falling down. When it cools down, it falls. When it heats up, it rises. It's that constant movement. Good examples that you might be familiar with: boiling water. Everybody's seen that. A radiator that heats a cold room. When you're very, very close to it, you're getting radiation heating, but it heats the whole room through the convection. How about a steaming cup of coffee or tea or hot chocolate? And the one you know, the Earth's mantle. Those convection currents. The hot magma heating up near the core, rising, it gets toward the lithosphere, the crust, and it cools off, and it falls back down again. This is what causes our plates to move. All right, if you have finished conduction and convection, you are ready to move on to radiation. It's heat energy that can travel in space by infrared or thermal radiation. It's a type of electromagnetic radiation. Sometimes we call it EM. It does not rely on physical contact of substances. When it says physical contact, that means direct contact. I don't have to touch anything. Unlike convection and conduction, okay, it is traveling through the air or traveling through space. Some examples you're probably familiar with: a campfire's heat. If I want to heat up my hands around a campfire, I'm going to hold them back. I'm going to let the electromagnetic waves come to me. I'm not going to put my hand in the fire. A microwave heating up food. A light bulb. Okay, if I put my hands right around a light bulb, they're probably going to get warm. Infrared food warmer in a restaurant. You don't see these a lot, but you do see them sometimes in the back of a restaurant or on a hot meal bar.